This video we are going to look at balancing. I'm going to show you two different ways of balancing. This video will focus on balancing by oxidation numbers, and the next one will focus on balancing by half reactions. So both methods get you to the same kind of end point. They just use different ways to get there. For the most part, usually we'll show you both ways, and then whichever way seems to work better for you is the way that we want you to focus on doing it, right? The important part is being able to balance them, not necessarily which one you can use. A question is never going to say you have to use this method or you have to use that one. It'll just say you have to balance it, okay? So before we get into that, we're just going to talk really quickly about disproportionation. I'm not going to spend a lot of time on this. If we were in class and writing a diploma, I would, but we're not, so I won't. So disproportionation is a big word. Basically, it means that the same species is being both oxidized and reduced. So generally how I'm going to recognize disproportionation is if I were to assign oxidation numbers. So if I were to look at this, I would say I have chlorine, that's Cl2, that's the elemental form. So it has an oxidation number of 0. Then I have water. I know that the oxygen is going to be -2, and I know that the hydrogen is going to be +1. Right? Then we have HCl. So we know in here, the hydrogen is +1. So by default, the chlorine has to be -1. And then here we have HClO, so we know the O is -2. We know the H is +1, which means our chlorine is going to have to be +1 as well, so that the sum of those oxidation numbers equals 0. So when we look at this, we're going to find that this chlorine changed here, right? It went from 0 to -1. And then when I go to figure out what else changed, the H didn't change, the O didn't change. It was actually this chlorine did two things, right? In one case, it went from 0 to -1. In the other case, it went from 0 to +1. So here we have the gain of electrons, and here we have the loss of electrons. So disproportionation is when it is the same species, in this case the chlorine, that underwent both reduction and oxidation, okay? So don't need to spend a lot of time on it. Like I said, normally we would, but here, that's what disproportionation is. Generally, we're not going to ask you to do anything with it. If you were writing the diploma, it usually would ask you to recognize one, at which point, I don't want to say it's always chlorine. It's not always chlorine, but a good chunk of the time, the disproportionation reactions are chlorine. Sometimes it's like one of those things that we talked about that has the ability to either be an OA or an RA, right? So like an SN2+ with an SN2+ turning to SN and SN4+. But that's usually where that goes, okay? All right, so let's look at balancing by oxidation numbers. So we have rules, or steps, I guess I should say, that we need to follow when we are balancing by oxidation numbers. So you're going to find they're always going to give you like a skeleton or a base frame to start from, okay? So from that, you're going to start by assigning oxidation numbers. So to every single atom that you have, you're going to assign oxidation numbers. Then you are going to draw linker lines connecting the atoms which change, right? Which is what we did in this last slide here, right? Like when I connected these, those are what we call linker lines. Once you have drawn those linker lines, you're going to write on the line how many electrons were lost or gained, right? So we did that in a previous video when we were looking at, was this equation redox? We wrote lost 2 electrons, gained 1 electron kind of thing. So you're going to write that on the line just by looking at what those oxidation numbers are. So the next thing you need to do is if the atom which changed has a subscript, right? So let's look at that last we did here, right? This chlorine here has a subscript of 2. So what I would have to do is indicate on my linker line that it had a subscript. So it doesn't matter if this one has the subscript or this one has the subscript or they both have the subscript. If you have that, you must multiply the gain or loss by that subscript. And the reason you have to do that is when we assign our oxidation numbers, they are for a single atom. But if we have like a Cl2, we can't have half of the Cl2 react. Either we have a whole Cl2, we have 2 Cl2s, we have 3 Cl2s, right? We can't have an individual Cl. That's just not possible. So if you don't have a subscript, you don't need to multiply by anything. But if you have a subscript, you must multiply by that subscript. Then what you need to do is look at the total loss and the total gain. And if you had to multiply by a subscript, you would take that into account. If they're already the same, then you don't need to do anything at that stage. You can kind of skip this step. But if they're not the same, so let's say this one says gain 2 and this one says loss 3, I have to make the electrons the same, right? And that's something we've talked about all unit long, that whatever we lose, we also have to gain. So if I had 2 and a 3, I would have to multiply by a 3 and a 2 so that I could get the total number of electrons to 6, okay? So once you do that, that number that you had to multiply by is going to tell you what the coefficient is that needs to go in front of the chemicals that are on that linker line, okay? And we'll walk through a couple examples showing you how to do that. If you had a subscript, if both of them had the subscript, good to go. You don't have to do anything. But if one had it and the other didn't, you would have to take that subscript into account and make sure that you either double or triple whatever that subscript was, the coefficient for the partner of that pair that didn't have the subscript. Okay, so that is going to take care of balancing our electrons. You will still sometimes find, though, that your atoms are still not going to be balanced. So how we're going to fix that? We're going to add water to balance the oxygen. So I'm going to count how many O's on this side, how many O's on this side, and from there I'll figure out how many waters I need to add. And if they're already balanced, I wouldn't add any waters. Next step, you're going to add hydrogen ions to help you balance out those hydrogens. So count H's, count H's. They're the same, you don't need to. If they're different, you need to add to whatever side needs to raise the number of hydrogens. Okay, once you do that, it should be balanced. Okay, there are a couple of questions where sometimes you have something where there's no linker line drawn to it and you're going to have to site balance it. And we have an example of that and you'll see what it looks like. But yeah, most important step, which is also the step you guys tend to skip. Make sure it's balanced. So once you've done all that work, and it is quite a bit of work, make sure that it's not for nothing, right? Check to make sure that your atoms are balanced and check to make sure that your charges are balanced. Okay, and this is where you're going to find, like I was talking about in a previous video, writing those oxidation numbers in a different color makes it a little easier when you're trying to check your charges. Otherwise, sometimes you guys start counting oxidation numbers as charges, and you don't want to do that, okay? Okay, so let's have a look at our first example, okay? So we're going to walk through those rules as we solve this question. So first step that we had to do was to start by assigning oxidation numbers to everything. So here we have zinc. This is zinc as an element, so it gets an oxidation number of 0. Here we have a nitrate. So we have oxygen. We know oxygen is -2. Okay, we have N. So if we have 3 oxygens, we have -6 coming from that. We need to leave 1 because the overall charge is -1. So that means the N, sorry, I'm still coughing, like 2 months later, is going to be +5. Okay, we go over to this zinc. It has a +2 charge. So it has an oxidation number of +2. Then we have our NO2. So O is going to be -2. The N, because I have 2 times -2, I have a total of -4. It's going to be +4. Okay, so that was step 1. Assign all of those oxidation numbers. Okay, then what we're going to do is we're going to draw linker lines for the ones that change. So zinc went from 0 to +2. So we are going to link those. And then the other one that changed is going to be our nitrogen. It went from +5 over to +4. Okay, so once we've drawn our linker lines, our next step is going to be to indicate the gain and loss of electrons. So when I look at zinc, it went from 0 to +2. So that means we lost 2 electrons. Okay, now we're going to look at the N. It went from +5 to +4. So that means we gained 1 electron. So the next step was check for subscripts. Okay, this zinc has no little number, so I don't have to do anything for it. The nitrogen, there's no subscript, no subscript. I also don't have to do anything for it. So next step is to make the gain and loss the same. Right now I've lost 2 electrons and I've gained 1. So I'm going to have to multiply this by 2, right? Multiplying that by 2, 2 times 1 is 2, is going to make my gain and loss the same. So what we're going to do is, because we had to multiply by 2, this determines the coefficient that's going to go in front of this and in front of that. Okay, because the linker line goes to those two things, we're going to put a 2 here, and we're also going to put a 2 here. Okay, so I'm not going to put any coefficient in front of these zincs. And the reason I'm not putting a coefficient in front of the zincs, I didn't have to multiply by anything, right? We didn't have to say times by something on this linker line. So I'm not going to write anything there. These both get a 2 because I had to multiply by 2. So at this stage, we've taken care of balancing our electrons. The next thing we need to do is balance our O's. So when we look on the left side, there's no oxygens here. There's 2 times 3, so 6 oxygens here. So right now we have 6 O's on the left side. We look at the right side, we have none, and then 2 times 2, so 4. So if we have 6 electrons over here, or not electrons, sorry, 6 oxygens over here and 4 oxygens over here, we're going to have to add 2 more waters over here. Fix my formatting up a little bit so this all fits on the same line. Okay, so we're going to add that. So now I'm going to make all my linkers not line up, but maybe I can make the font a little smaller. That looks a little better. Okay. All right, so now we've added water, and that is taking care of balancing out our oxygens, right? So now we have 4 O's plus 2 more. So I have 6 O's matching my 6 O's. The next step was to balance my hydrogen ions. So there's no H's on the left side. Because we added these waters over here, we have 4 H's over here. So what we're going to do is on this side, we're going to add 4 hydrogen ions. Okay, so that is going to now take care of balancing that. So now when we look at this equation, it should, if we have done everything right, be balanced. So let's check. We have 4 H's and we have 4 H's. So the H's are good. Then we have zinc. We have 1 zinc, 1 zinc. So those are good. 2 N's, 2 N's. We have 6 O's. 4 plus 2 equals 6. So atom-wise, we are balanced. Now we need to check our charges. We need to make sure that our charges are balanced. So this is where writing my oxidation numbers in a different color is helpful, because I am not taking oxidation numbers into account when I'm worried about charges. I'm looking at these actual charges, which are in black, which makes it a little easier to tell what they are. So if I look at this, I have 4 H+, so I have 4 positives from this. This has no charge, and this has 2 negatives. So if I have 4 positives and 2 negatives, right now the charge over on this side is +2. If we check this side, I have +2 from the zinc, nothing from this, and nothing from this. So my charge is balanced. Both sides have a +2 charge, and my atoms are balanced. This means my equation should be good. The only potential way to find that everything balances, but my equation isn't actually right, and this is something that also happened every other time you've balanced, is sometimes you find that you don't have the most reduced set of numbers, right? So right now I have a 4, a 1, a 2, a 1, a 2, a 2. But if I had like an 8, a 2, a 4, 2, a 4, and a 4, it would still be balanced, but everything there would be capable of being divided by 2. So do make sure that you are checking, especially if you start getting into bigger numbers, that your equation is the simplest form and can't be reduced past where it is. Okay, so let's try another example, just because you will honestly see when it comes to balancing these questions, they're all different. So the more you practice, the easier it becomes. If you only try 1 or 2, we could throw a different question at you and you'd be like, I have no clue what to do. So really important to make sure that you practice these because they are kind of a relatively large concept in this unit, okay? All right, so let's continue going through them. So what doesn't change from question to question is the steps that you follow, right? So that's definitely something to make sure that you are familiar with. Normally in class, we would say you have to have memorized it, but obviously the only way we're really going to be assessing this is through those one-on-one conversations at the end of the unit. So when you're doing those, you definitely want to make sure that you are prepared to balance and that you know those things, okay? All right, so we have Ag2S. So we're going to have to go to our electronegativity to determine what we're going to start with because we don't have H, we don't have O, like we don't have a group 1 or a group 2. So silver is 1.9, sulfur is 2.6. So the sulfur is going to get an oxidation number matching its charge. So it's going to be -2. Because we have 2 silvers, they are going to be +1. Okay, we have aluminum, there's no charge, so it's 0. We have Al3+, so it's going to be +3. Okay, we have an S2-, so it's going to be -2. And then we have Ag, so it's going to be 0. Okay, so step 1 is done. Step 2, draw linker lines for things that change. So silver was +1. And then it turned into 0, so that changed. And then aluminum changed, right? The sulfur didn't change. It was -2 and it was -2. So we're not going to draw any linker lines to it. That doesn't mean I can just completely ignore it. It means at the end, I'm going to have to come back and figure out what number needs to go here based off of what number I put over here, okay? So there are some questions where there is a little bit of a site balancing aspect to them when you have not drawn linker lines to it. Okay, so silver went from +1 to 0. So that means the silver gained 1 electron. We look at aluminum, it went from 0 to +3. So that means we lost 3 electrons. Okay, next step, check for subscripts. The silver has a subscript of 2. So we need to say that this is ×2. Okay, so when we are accounting for a gain and loss of electrons, we need to recognize that although individually we lost 1, that's always going to be multiples of 2, which is why we've done that ×2. Okay, it doesn't matter that this one doesn't have a subscript. The fact that this one does, I have to account for it. Okay, we look at aluminum, no subscript, no subscript. We don't need to multiply by anything. So next step is going to be to make the gain and loss the same. So we lost 3. The gain is 1 times 2, or 2 electrons. So if we lost 3 and gained 2, our lowest common multiple is going to be 6. So for our loss, we're going to have to multiply this by 2. And for our gain, we are going to have to multiply this by 3. Of course, that messed some of my formatting up here. Hold on a sec. Should put that all in the same one. Okay, there we go. So now we have 2 times 3, which is 6, 3 times 1 times 2, which is also 6. So when we want to write our coefficients in, so let's do the aluminum because it's the easier one because we had no subscript. We had to multiply by 2, so that means we are going to put a 2 and we are going to put a 2, okay? So why I saved the silver for second. This one has a subscript. This one does not have the subscript. If they both had the subscript, I would put a 3 in front of both of them. But because they don't, what we're going to find is the Ag2S is just going to get a 3. And that's because it already has the subscript of 2. But this silver isn't going to get a 3, right? If I put a 3 here, I would have 6 silvers to 3 silvers, and that doesn't work. So when one has the subscript and the other one doesn't, whatever this coefficient is, you have to multiply it by that subscript. So 3 times 2 is 6. So we are going to put a 6 for our Ag. Okay? So waters, we don't need to add any waters, and we don't need to add any waters because there are no oxygens anywhere in this equation. Hydrogen ions, don't need to do that either because we don't have any hydrogen ions in this equation. However, what we do have to take care of is the sulfur, right? Right now I only have 1 over here, but if we look here, we have 3 of them. So this is that site balancing piece where we're going to put a 3 in front of it, okay? So next step, let's make sure it's actually balanced. So 3 times 2, 6 silvers, 6 silvers. 3 sulfurs, 3 sulfurs. 2 aluminum, 2 aluminum. So atom-wise, we're good to go. We are balanced. Charge-wise, there's no charge on the Ag2S. There's no charge on the aluminum. So 0 charge on the left side. We look at the right side, 2 times plus 3, so we have plus 6. 3 times -2, -6. This has no charge, so plus 6 minus 6 is 0. So this is balanced on both the charge front and the atom front. Do a quick check to make sure it can't be reduced. It can't. And so that's how you would do that question. So it looks a little different because we had that subscript and we had to account for it. So make sure you are checking for that because sometimes you guys forget about the subscripts and then you're like, I can't make this question work. I've tried it like 5 different times. I'm super stuck. I don't want to say it's always the subscript. It's not always a subscript, but it's definitely a common issue you guys have is that you forget to account for that subscript. Which is why it's really important to make sure that every question you're kind of going through, do this, do this, do this, do this, so that you don't miss something on a question. Okay, let's do one last one. Actually, no, let's not. So this would be a disproportionation question. Like I said, we're choosing not to worry about disproportionation this year, mainly because we are in emergency remote teaching and some things just have to go, and disproportionation is kind of one of those things because it's not a super major important thing. It's super small and usually you guys forget about it anyways, okay? So this is how you balance by oxidation numbers, right? So that was 2 different examples for you. You have a whole bunch more problems for you to practice in your booklet. Out of the 2 methods, I would say this is the method you guys tend to prefer the least. And I think it's because there's a lot of spots to make a mistake, right? If you make a mistake assigning an oxidation number, the question will never work. If you make a mistake assigning how many electrons were lost or gained, it will never work. If you make a mistake with a subscript, the question just won't work, right? And this is why that final step of check to make sure it's balanced is really important. Because a lot of times you guys are just like, oh, I finished the steps, I'm good to go, I'm done. But then it's not actually balanced and you miss that, right? So do make sure that you spend that extra 5 seconds to make sure that it's actually balanced. If it's not balanced, start the question from scratch. And I only say that because I can tell you with these questions, when you guys just try to find where your mistake is really hard to find where it is. Even for me, when you guys are in class and you come up and you're like, Miss Chip, this isn't working for me, I'm stuck, I can't figure out where I've gone wrong. You'll find I'll never actually look directly at your work. I'll do the question on paper until I can see where it's gone wrong, because what tends to happen is you look at your work and you're just like, oh yeah, it all makes sense. It's good. I don't know what's happening. But you'll find if you just restart the question, usually you'll see that you do come up with a different answer. And it's usually something small, where just in your head you decided it was something, and so even when you looked at it again, because in your head you were sure it was something, you still kept sure of that something, okay? So yeah, that's basically how you're going to balance by oxidation numbers. Next video is going to show you how to balance by half reaction method.